Howdy howdy guys, welcome back to Cruiserman's Inventions. We have got another generator little test going on here. So this is a fish and pike core washing machine stator rewired back to 12 times 1C. It generally is stock standard at 1 times 12C, which looks like that. And so here, every 3, as you can see, is tied off at the end, giving you 12 groups of 3, so which is also 12 volts in every 3. Now let's have a look down here, guys. So what I've done is I've got a little test going on here, and this is the generator here, right here. Yeah, the lighting's not the best. So I've also made this handle this morning. I can just hook on here so I can turn it to show you what the voltage is just straight from itself. Here's the volts meter. It's on DC 200. I've also got a bridge rectifier out of an alternator here, and I just put on these 2 capacitors, which were 400 volt at 2200 UF, which come out of these battery chargers for e-bikes. And this is another bigger one that I blew up just recently because I wasn't watching what I was doing. And this is the insides, a little bit of the insides, and this is where the capacitor came from. I did try and fix them, it's just that, I don't know, it didn't work out. So anyway, we'll get rid of that junk. So let's bring in a battery. This is a 20 ampere battery. It's a 12 volt one, but close to 20 amperes. Yeah, 18.9 amperes. So what we want to do first, guys, before we hook it up to this battery. Oh, the reason why I done this, guys, and put these 2 capacitors on here like this, and join the 2 negatives together and the 2 positives together, basically, and then came off with 2 separate wires coming back down to where it would be DC anyway. This bridge rectifier that came out of an alternator had a little capacitor on it. Here it is here, but it wasn't holding volts. It wasn't holding the voltage, so I added another 2 here. They came out of those chargers, and AC comes in, as you know. AC comes in, and it comes into the back side here, and it changes to direct current out through these other 2 wires, negative and positive here. So 3 and then into 2 AC DC, right? So these help hold whatever power runs through it. Okay, so I'm going to put on the clips over here to the negative, and the other clip of this meter to the positive. And then I'm going to turn this, and as I'm turning it, you're going to see the volts going up. Now that's 10 volts right there. That's DC. 11 volts, 12 volts. Keep going. If I go fast enough, I could get it right up to 24. But let's just stop for a minute. Now you see that? That's how good these capacitors are. They're actually holding the volts there, and which is a good thing. That's what you want for charging purposes. You want good, you know. Oh, and that's the other thing, guys. There's no residual forces. This thing's still free as a bird, with all of that stuff on there. There was another way I'd done it before. It really binded it up like a brake, and wasn't the best. But the 2 negatives together, the 2 positives together. These capacitors, they have, I don't know if my camera can see it, but they, down along this gold mark, they have these like negative bars going down, so just keep that in mind. So anyway, let's have a look at this battery and how many volts it is. Okay, so it's a 12 volt battery, and let's pull off these plugs for a minute, put it on here. I want you to see the volts of this, okay, which is 7 7.6. There you go. Now, let's flick it back down to 20 volts DC, right there. And it says, yep, 7.5. Let's put this somewhere where the camera can see it. 7.5. Now what I'm going to do is, I've got these clips over here, and got my two my negative one rather, and a crocodile clip to hold it on here, right, like this. That's one, and then this is the other one. Here it is, 2. Okay, now that's on. So we know that it was 7.5 volts in this battery. Okay, so those clips are on now. At the end of these crocodile clips here are the other ends. So that's where I'm going to put my voltmeter, negative and positive, and that's what's going to give us our reading. Back to the meter. Yep, 7.5. That's what's in the battery already. Now, let's give it a little whirl. Keep that number in your mind, 7.54. Right. Without disturbing up these wires. Whoops. Everything's so tight here. Hang on. See if I can turn it around without knocking these to pieces. Alright. Oh boy. So tight. Alright. Let's move it out a bit more. Not going to bump it. Okay, here we go. Okay, now I'm just going to turn this for a little bit. Now you can see the volts going up. That's all DC power going into that battery. I haven't charged this battery up for months. I just went and got it. I know it's not too bad a battery. It can be charged up to well over 12.5 if I needed it. And so as I'm going, guys, you see the volts there? So as I just stopped now. Remember that number? See? So volts are going into it just straight away. 8.5, 8.7. You know, it's dropping down because this wasn't generating for very long. The longer you generate, you know, keep something turning for, you know, the better it's going to be. The more your battery's going to hold that power in. But those capacitors, with no residual forces on this thing, is excellent. Man, you can't beat that. That's the very thing you're trying to get away from, is anything that's going to make these things as a brake, right? So the alternator full bridge rectifier is amazing on this thing. There's no look at that, it's so easy. I could just spin it and let it go, you know, it's just free. And that's charging something. So you imagine this is a windmill. There we go. Chicky boy. So 8, there we go. Let's speed it up a bit. Let's really push some stuff through as fast as I can. Really pushing power into it. Oh, alright. Yep. There, it's already close up to 8. It's dropping back, settling volts. But it's still past 1.5. It's getting close to 8. Not too bad. Yeah, it's not too bad, guys. Not too bad. All right, so it's still going down a little bit, but it's past 1.5. What it was, it's 1.8 now. So, and that didn't take very long, just off that. So that's because there's really 12 generators in this thing. The way that it's wired, you know. Let's one more look. Look, it's gone up 1.8. Oh, I mean, sorry, 7.8. Yeah. Yep. Wow, that's impressive. That is impressive. Yeah, this is my old test bed. That's why I just left this here. I am on the windmill build, guys. So go and check that out. This thing's going to be, pretty big. But this is not the wire stator I'm going to be using on the generator. I mean the windmill. It's another one I have. Which is actually it's this one here, which is, which you can see in my other video. It's every 12 poles. Well, it's 12 poles times 2, gives me 105 odd volts, give or take the speed of the windmill. And then I have another 6 here, which will give me about 36 volts up to 48 volts, roughly, depending on the speed. So yeah, that one's going on the windmill, but this one here is the one that everyone's after. It's you know, because of 12 volt charging and stuff like that, and everyone relates to this one, so I thought it'd be cool to do a video. And here we go, one more little look at that down here, guys. See, it's still 7.72, and when we started it was 7.5. So just goes to show, with a little bit of tuning, there you have it. Of course, I just made this up for testing purposes of this video, and just to plainly show you guys all this stuff working. So yeah, awesome guys, cool little system for charging 12 volt batteries. Bridge rectifier and 2 more capacitors. So yeah. Awesome stuff, guys. Right, I better get back to work and start on this windmill project now. Cool, guys. See you in another video coming up. Cruiser Man out, guys.